Hello viewers, today we'll talk about strong consistency and eventual consistency. So let's get started. So consistency, what is meant by consistency? Consistency tells you that whether data is consistent across all the sources of data. So if we have distributed system, then in all the databases, the same data has to be present and user is able to see the same data when on the web or mobile. So in case of consistency, for eventual consistency, propagation of latest update might take a few milliseconds longer. It is possible to miss the latest update, but when you will refresh, you will get the latest data. But in case of strong consistency, you will always read the latest update. In terms of performance, in case of eventual consistency, it is fastest possible reads, whereas strong consistency, in case of strong consistency, it is slower than eventual consistency reads. In terms of cost, eventual consistency is cheapest possible reads. Two eventual consistency reads cost 1 RCU, whereas in case of strong consistency, it is twice as expensive as eventual consistency reads. Each strong consistent read cost 1 RCU. What is eventual consistency? Eventual consistency is a theoretical guarantee that provided no new updates to an entity are made, all the reads of the entity will eventually return the latest updated value. The Internet Domain System (DNS) is a well-known example of system with an eventual consistency model. DNS servers do not necessarily reflect the latest value, but rather the values are cached and replicated across many directories over the internet. It takes a certain amount of time to replicate modified values to all the DNS clients and servers. However, the DNS system is a very successful system that has become one of the foundation of the internet. It is highly available and has proven to be extremely scalable, enabling name lookup to over 100 million devices across the entire internet. What is strong consistency? In contrast, traditional relational databases have been designed based on the concept of strong consistency, also called immediate consistency. This means that data viewed immediately after an update will be consistent for all observers of the entity. To have strong consistency, developers must compromise on the scalability and performance of their application. Simply put, data has to be locked during the period of update or replication process to ensure that no other processes are updating the same data. So let's see the use case of eventual consistency. Eventual consistency is a consistency model that enables the data stored to be highly available. It is also known as the optimistic replication and is key to distributed system. So in case of the applications such as Twitter or Facebook, think of a popular microblogging site which is deployed across the world in different geographical regions like Asia, America, and Europe. Moreover, each geographical region has multiple data centers, which is north, east, west, south, everywhere. When someone likes a feed in North America, for example, and in Asia, if you are looking at it, you might not see the latest result immediately. So the data store service is highly available. Even if a few nodes go down, persistent service is still up. Let's say a celebrity makes a post on the website that everybody starts liking around the world. At a point in time, a user in Japan likes a post which increases the like count of the post from say 100 to 101. At the same point in time, a user in America in different geographical zone clicks on the post and he sees like count as 100, not 100, 101. But whenever he will refresh, he will see eventually 101. So eventual consistency is a consistency model that enables the data stored to be highly available. It is also known as optimistic replication and is key to distributed system. So when the user refreshes the web page after a few seconds, like counter values will show as 101. So the data was initially inconsistent but eventually got consistent across server nodes deployed around the world. This is what eventual consistency is. Now let's see the strong consistency use case. Strong consistency simply means that data must be strongly consistent at all the time. All the server nodes across the world should contain the same value as an entity at any point of time. So in the same example of like button, when a user sees 100, it is 100 will be seen across all the regions, and if someone like again the same feeds, then 101 will be seen across. So once all the nodes reaches consistency, lock get lifted. Now other users can like the post, but it increases the latency. If the node takes a while to reach a consensus, they must wait until then. Well, this is surely not desired in the case of social applications, but think of a stock market application where the users are seeing different price of the same stock at one point in time and updating it concurrently. This would create chaos. Therefore, to avoid this confusion, we need our system to be strongly consistent. In case of stock market, the node must be logged on for updates, queuing all the requests in one good way of making a system strongly consistent. The strong consistency model hits the capability of the system to be highly available and perform concurrent updates. In case of eventual consistency, whenever we use multiple replicas of a database to store data, and let's say a write request comes to one of the replicas, in such a situation, database has to discover a strategy to make the write request at one replica which reach other replicas so that they all could see the right data of the request and become consistent. Eventual consistency makes sure that data of one node of the database gets consistent eventually. Time taken by the nodes of the database to get consistent may or may not be defined. Data getting consistent eventually means it will take time for updates to reach other replicas. So what? This implies that if someone reads from a replica which is not updated yet, since replicas are updated eventually, then they may return the stale data. In case of strong consistency, it says that data will be passed on all the replica as soon as the write request comes to one of the replicas of the database. But during the time these replicas are being updated with new data, response to any subsequent read-write request may a request by any of the replicas will get delayed, and as all replicas are busy in keeping each other consistent, as soon as they become consistent, they start to take care of the requests that have come at their door. In case of eventual consistency guarantees that if an update is made to the data of the node, say node n, then the update's value will be eventually will be propagated to the replicas of that node, and eventually all the replicas will become consistent to the original node n. Nodes will get eventually consistent means it will take time for updates to each other replicas. Hence, eventual consistency is a consistency model which is used to achieve high availability and is a weak consistency model. In contrast to eventual consistency, in case of strong consistency, it guarantees that if an update is made to a node says and then the updated value will be propagated to all the replicas n1 and n2 of the nodes and immediately. In other words, after the update completes, any subsequent access to n or n1 or n2 will always return the updated value. Note during the time these replicas are being updated with new data, any read-write request to any of these replica will get delayed as all the replicas are busy in keeping each other consistent, and once they will become consistent with the original node, they will start accepting read-write request again. In case of eventual consistency, an eventual consistent model guarantees that whenever an update is made at a node of a distributed system, which will eventually be replicated across all the nodes as long as no new nodes updates are made to the entity during that time. This makes the data at all the nodes consistent to the originally node eventually. Eventually, all the clients will see the updates. Here the stress is on eventual, which means that it can take some time before the updates value is synchronized across all the nodes. In a strongly consistent system, all the replicas are updated with the most recent value as soon as any of the replicas responds to write request. However, during the time interval that the data is being updated in the replicas, all read-write requests made to any of the replicas will be delayed. The replicas will only respond to the request once all the nodes receives the update. In other words, the client will get a response for their request once all the nodes of the system are consistent. So thank you so much for watching today's video, and if you think the videos are helpful, do like the video and subscribe to the channel.